Alright, let's see. What are we doing today? Are you sending me something, or are we going to this page right here?
We're going to the homework on the website.
Okay. And which lesson?
7. So out to, yeah.
I think I gotta go back to 7. Yeah, okay. 7 what?
I think 0.21.
7.2.1.
And it's 116 and 117.
Okay. Okay, well, let's talk about what the graph of y equals sine of x looks like. Since you can't draw it for me, I'll draw it. It's the one disadvantage of online, is when you need to draw something. So that's y equals sine x. Okay? If I move that thing up 1 unit, what's the equation? If I do a vertical shift up 1 unit, what equation does that give me?
Um, I'm not sure.
Well, it's a vertical shift, so the only thing I'm doing is adding 1 to the whole thing like that. And the result is every point on there moves up by 1. So it's exactly the same shape. It just looks like that instead. Okay? So the blue curve is that. It's a vertical shift by 1. What are the intercepts of your new equation? What does it mean by that?
Where does it touch X and Y?
Yeah, so it's not x and y. Well, actually, you're right. What are the intercepts of your new equation? Well, there's the y-intercept. Where's that?
1.
Okay. And these are the two x-intercepts. So, what is y when I'm on those two x-intercepts?
0.
Yeah, very key point is when you're talking intercepts, the other variable is 0. In other words, when I looked at the y-intercept, I knew that x was 0. When I'm looking at the x-intercepts, I know that y is 0. So all I got to do is substitute 0 and solve that equation. So now I get 0 equals sine x plus 1, means sine x equals minus 1. Where does that occur? Hold on a second. Okay. Well, where does sine x equal minus 1?
Um,
There's something I'm missing here, and I can't figure out what it is. Label them with the coordinates on the graph. So here's our equation. It's a vertical shift. And if I solve that equation, I get sine x equal minus 1. And that only occurs at one place. That's 3 pi over 2. And yet there should be two answers. If I look at question D, notice I only gave one answer. And then if I look at question D, did you list more than one? Well, I can see from my graph that I should have two. How come I only came up with one? Furthermore, the one that I came up with is right there. That's not right. Well, that's not very helpful. Let me think about this for just a moment, because I'm extremely puzzled as to why this is giving me problems. There's no math I know better than trig. So here is the sine of x. If I take that and I shift it up 1 unit, every point goes up 1 unit. No, that's shifted up too. So it looks like that. And I'm trying to figure out what those 2 points are. Well, this equation is y equals sine x plus 1. And since I'm trying to figure out the x-intercepts, I set the y equal to 0. I solve it. I get sine x equals minus 1. The only place that sine x is equal to minus 1 is right there. I feel like I am making a huge mistake, and I'm staring right at it and I can't see it. So the only thing I can think of to do is to go on. Okay?
All right.
I can't, in other words, the blue line would tell me that x is, that's 3 pi over 2, and that's where x is equal to minus 1. I don't know how to deal with this. Let me just go to the next one. You said 116 and 117?
Yeah. In this section, there's like another section.
Right. Okay, here we have the sine curve shifted to the left, right? You can see that. In other words, normally this starting spot would start right at the origin. In other words, it would typically look like this. So all I've done is taken my red curve and they've shifted it to the left by pi, because that's at minus pi. So, first question, how many units to the left was it shifted?
Would it be minus pi?
Actually, the answer is going to be pi,
Okay.
because they already told you that it was to the left. So it's not minus pi, it's pi.
Okay.
It ends up being this point is at minus pi, but that's because they shifted it to the left. Okay. Now, figure out how to change the equation so that the graph of the new equation will look like the one in part A. If you do not have a graphing calculator, sketch the graph and check your answer when you get to class. Well, when you do a horizontal shift, it's inside the parentheses. So when I'm shifting to the left, that's my answer.
Okay.
If I am shifting to the right, then it's going to be sine of x minus c. If I was shifting c units to the right, this is the form it would be in. Since I am shifting pi units to the left, changes that sign to a plus instead of a minus, and c becomes pi, the amount that we shifted. So this one's rather easy. Y equals sine of x plus pi, because it has to fit that format. And when you shift to the right, it's minus that amount. When you shift to the left, it's plus that amount. Okay, what's next?
So now let's go to, I think, so a new chapter, so 7.22.
Okay. And which problems?
And 129.
All right, this is going to require a bit of training. Here is the standard formula for a sinusoid function. Let me write it. These look hard, but they're actually pretty easy. Okay. You seen this?
Yeah. Like, we just got introduced to it, so.
Okay, well, this is my standard formula. This is the one you want to memorize. Now, if we can come up with A, B, C, and D, we'll have our answer. And believe it or not, it's not as hard to come up with as you think. So, let's talk about it. A is the max minus the min divided by 2. What's A? So, there's a maximum value, 3.
Okay.
There's a minimum value of 1. Subtract them, divide by 2.
It equals 1.
Okay, so that's A. D, the next easiest thing to figure out, equals the maximum plus the minimum divided by 2. So what's D equal to?
It would be 2.
So we've got half the answer. Okay. Now, the two hardest things to figure out are B. B is equal to 2 pi divided by the period. The period is the distance from trough to trough, or peak to peak. The only things I can see on that first chart are trough to trough. What's the distance between the troughs? In other words, what's the distance between that point and that point?
2 pi.
Correct? So that's the period, 2 pi. What's B?
Would it be 1?
Okay. And that's how we're going to do every one of these problems. We're going to figure out what A, B, C, and D are. And then we're going to know our equation. Okay? Now,
Do we just have to get the equation, or do we solve the equation?
no, you just have to come up with it. Because all they ask for is the equation of each of the curves you're looking at. Now, C, the last thing, is the amount that it's been shifted left or right. Okay? Well, I'm using sine. That doesn't have to be sine. We can use sine or cosine with the sinusoid function. In this case, I'm going to take the easiest method and use sine. Okay? Now, if I were to draw a sine curve, the sine curve starts right there, right?
Yeah.
In other words, if I were to draw a non-shifted sine curve, it would look like this. So how far has this been shifted, and which way? In other words, relative to my unshifted sine curve, which is the red curve, the black curve has been shifted how much and which way? Compare
1.
this point and this point.
Would that be
It's this distance.
pi?
It's this distance right there.
Pi 4? Pi over 4?
Pi over 4 to the right, which makes C a positive. So now we have our answer. The answer is A is 1, B is 1, C is pi over 4, and D is 2. So there is our answer. In other words, once you solve for A, B, C, and D, then you just plug them into your sinusoid function. It's that easy. I mean, maybe it doesn't seem like it's easy, but it actually is. Because it's pretty easy to solve for A, B, C, and D. You do have to memorize some stuff. You have to remember that A is the max minus the min divided by 2. You have to know that D is the max plus the min divided by 2. You have to know that B is always 2 pi over the period. which means you have to read the period from the graph. That's the distance of one cycle of that curve.
Wait, so in this instance, did you just get rid of like all the ones? Like they're just not necessary to put in?
Exactly.
Or,
There's a
or
one
A and
right
B?
there. There's a one right there. Those are
Okay.
the only two ones that I didn't put in.
Okay.
Yeah, you don't ever put ones in. Okay? Unless it's a vertical shift. If it had been a vertical shift of 1, then I would have needed a plus 1. But if it's a multiplier, you don't put them in. Okay? The toughest part of this problem was the horizontal shift. In other words, figuring out, well, the first thing you want to do is draw what the normal curve, the non-shifted curve would look like. Okay, the non-shifted curve looks something like that, right? You got to be able to know what the sine curve looks like. That's an absolute must, is you have to know how to draw a sine curve or a cosine curve, either one. Okay, once you know how the original curve should look like, the non-shifted, then all you have to do is figure out what this distance is between there and there. That's how much it's been shifted. And that distance is, as you correctly surmised, pi over 4, half of pi over 2. Okay, so let's do another one. Now, I'm going to start off by writing we're going to be doing B, but here, let's write our standard. This one I'm going to use cosine, even though it is called the sinusoid function. You can use sine or cosine. Why did I choose to use cosine for B?
Because the graph has points on
Well,
the
because
left.
the cosine curve looks like this.
Yeah.
Well, that's exactly what we're looking at. In other words, if I use the cosine curve, there is no phase shift. The only reason this had a phase shift, because it didn't start out being either the cosine or the sine. But remember what a sine curve looks like. A sine curve looks like this. So this point right there is the beginning of a sine curve. So I could see this one was horizontally shifted by this amount. But this one over here, I could use sine, but then I got to shift it by pi over 2, because here's where the sine curve would start. But cosine curve starts right there. So I'm going to use cosine curve and not have a phase shift. And that's always the preference. Whenever you decide which to use, sine or cosine, you're basing it on the fact of which one will give you the smallest phase shift. Okay? So I know this is cosine that I'm pointing at here on the far right, and I know this looks exactly like that almost. In other words, this has got a little bigger amplitude, and it's been shifted up a little bit. So we're going to figure out the same things. What's A?
It's
Maximum minus minimum
yeah.
divided by 2.
So it would be 2 minus -1.
Correct? Divided by 2.
Would it be half?
3 halves. 2 minus a -1, all divided by 2. That's 3 halves.
I
Okay? Again, let's do the next easiest. D. A and D are always easy. A is the max minus the min. D is the max plus the min. Divided by.
How'd you get 3/2 though?
What's 2 minus minus 1?
Isn't it just 1?
2 minus a minus 1.
Oh, -3?
No, that's positive 3. That's the same as these two minuses together turn into a plus. So it's 2 plus 1. That's 3.
Oh, okay, yeah. All right, yeah, I know. Sorry.
All right. So A is 3/2. Now tell me what D is. D is where you add the max to the min and divide by 2.
So it'd be 2 plus -1, which would be 1/2.
Correct? So that's D. Now, C is the toughest one to get. Excuse me, B, rather. We already actually figured out that C was 0, right? In other words, there's no horizontal shift here. That point, this point right here corresponds with this point right here. There's no horizontal shift, so I can say C is 0. So B is what I need. What's the formula for B? This is the only one that requires you to memorize an additional, well, not really. A is the max minus the min. B is always 2 pi over the period. So tell me what the period is here.
How do we find the period again?
It's one full cycle of the curve. In other words, if I'm looking at C, the period goes from that trough to that trough, or from that peak to that peak.
Okay.
Horizontal distance. So what's
would it be
the distance from this to there?
pi?
Come on, you're going from minus pi to plus pi.
Oh, 2 pi.
Okay, so the period is 2 pi. So again, B is 1. Now, tell me the final answer. In other words, we've solved for A, B, C, and D, and we know that it's this. We're going to use the cosine curve, not the sine curve. So what do we got?
Y equals 3/2 cosine parentheses x minus 0.
Just X. Okay.
Okay. Plus 1/2.
That's the way you do these. Every one of them done exactly the same. Now, I'll give you one additional tip on these. Whether you use the sine or the cosine depends on what is the biggest shift needed. Well, B was easy. There was no shift if we used cosine. A was pretty easy. If we use sine, there's only this tiny amount of phase shift. What am I going to use on C? Am I going to use sine or cosine?
Sine.
Well, if I use sine, there's my normal starting point for sine. So the amount of shift is going to be this amount, correct?
Yeah.
If I use cosine, here's the normal spot where cosine starts. So the cosine shift would be from there to there. Which one's smaller?
Sine.
No, the sine is this big distance here. Cosine
Oh,
is
okay.
that little distance.
Yeah.
So
Cosine then.
cosine. Okay. So the very first thing, we realize we're going to use cosine. So we're going to use this formula. Now we have to figure out A, B, C, and D. A is what?
It is
Give me the
max
max minus min divided by 2. That's the general. Now what does that equal to here?
3 minus 1,
Okay.
which is 2 divided by 2, which equals 1.
Okay, good. Now let's figure out the next easiest one. D.
D. So D equals max plus minimum divided by 2, which is 3 plus 1, which is 4 divided by 2, which equals 2.
Okay. Now, let's just do them in orders of the letters. Tell me the formula for B. What does B equal to?
2 pi.
2 pi divided by the period. So you got to figure out what the period is. So really, before we can do B, we have to answer the period. Tell me what the period is.
But is that the trough one?
Well, you can go peak to peak or trough to trough. Now, neither one of them are that easy because they don't fall on the proper spot. In other words, the trough, that's this point right there, which is difficult to see on the graph. Although not really. Okay, yeah, so let's go peak to peak. It's going to be the same. Trough to trough gives you the same period as peak to peak. It's just peak to peak might be a little easier. Wow, I don't know if it is or not. First of all, this grid that they gave you is really messed up. It uses 3 grids to go pi over 2. That means each one of those is pi over 6. Why would they make it so tough? Well, rather than figuring out that point there and that point there, let's go from this point to this point. Same distance, right?
Yeah.
What is that distance? I go from minus pi over 2 to 3 pi over 2. Subtract. That's all it is. 3 pi over 2 minus a minus pi over 2. What's that give you?
4 pi over 2?
Which is 2 pi. So the period is 2 pi. In other words, the period is the horizontal distance between those 2 points. But those 2 points are not easy to find on our grid. So I take the 2 points that are directly to the left of it. In other words, I go from that point to that point, since they're labeled really nice. That one says minus pi over 2. That one says 3 pi over 2. So I can figure out this distance real easy is 2 pi. Not so easy to figure out this distance is 2 pi. Although it is, I mean, it has to be the same. It's just one spot to the right. Okay? So if my period is 2 pi, what is b?
1.
Okay. Now the last thing is c. And that's generally the hardest. Although if you think about it, we actually figured that out. We addressed that at the beginning because I had to know which my phase shift was to figure out whether I was going to use sine or cosine. Well, I chose cosine. Why did I choose cosine? Because cosine normally starts right there. So how far has that been phase shifted? What is that distance?
Um,
What's the distance of each one of these grids? In other words, what is that distance right there?
uh, pi 4, pi over 4,
Pi over 6.
pi over 6.
I got to go 3 of them to get to pi over 2, right?
Yeah.
In other words, to get to there, I got to go 3 grid marks. So if each one of them were pi over 6 times 3, that would be 3 pi over 6, which would give you your pi over 2. Okay? So each grid is pi over 6. How many grid marks am I phase shifted?
2.
Okay, so times 2, that's 2 pi over 6, which is pi over 3. So that is my phase shift. Now the question is, am I shifted left or am I shifted right?
Left.
So it's got to be a negative pi over 3. If it was shifted right, it would be a positive c. So now tell me my final equation.
Y equals cosine minus pi over 3
Hold on,
plus 2.
hold on. X, you always need that x. And it's plus pi over 3 because it's minus c. Well, c was a negative number. So it's got to be x plus pi over 3 plus 2. In other words, you always got to start from your general. My general says x minus c. Okay? Well, I figured out that my phase shift was to the left, which is a negative phase shift. So if it's x minus a minus number, then it ends up being x plus that number. All right. These are tricky, but once you learn the secret, they actually are rather easy. So, they get harder. Let's go back and look at the other one more time, because I didn't mention something that actually I could have used. Hold on. And it might have been more correct to use it. In fact, the answer that they're going to give you probably uses the following. Here, I got to explain a couple things. That's y equals sine x. If I reflect that over the x-axis, I get that. Well, a reflection is a negative sign, right? So that's what that is. Up here, I'm going to draw the cosine curve. That's y equal cosine x. Well, if I reflect that one, it's that. That's y equal minus cosine x. So these are really our four starting choices. Notice that if we look at C, I used cosine because it was a phase shift of 2. Actually, pi over 3. Okay? But notice if I'd used negative sine, this curve right here, I only have a phase shift of 1 unit, 1 grid mark. And you always want to use the least phase shift. So remember the answer we came up with. The answer we came up with was y equals cosine of x plus pi over 3 plus 2, right?
Yeah.
Well, what if I wanted to use sine instead? Remember, you always have your choice. Well, everything is the same. My A and my D are the same. But in this case, I don't want to use sine. I want to use negative sine. Here's what negative sine looks like. Well, I'm almost looking at that. I'm looking at exactly negative sine that's been shifted only 1 grid mark to the right. So this is also an answer. 1 grid mark is pi over 6. That is actually a better answer than the one we came up with. They're the same. Those two are the same. It's just that the sine has a smaller phase shift. It's a phase shift of pi over 6 as opposed to a phase shift of pi over 3. So what I really wanted to use was not cosine, but negative sine. I didn't do it because I thought it unnecessarily complicated it a little bit. In other words, if you use cosine, the problem is relatively straightforward. You can see that it's phase shifted to the left by two of these grid marks. But if I use negative sine, it's only phase shifted by 1 grid mark to the right. And I always want to use my smallest phase shift. So this is actually the proper answer for C.
Okay.
By proper, I mean they're both correct. But the general rule in math is you use the one that has the least phase shift. But both would be correct. They're not going to mark you off on either one here. Notice that it says it's an inverted sine curve. So the A value will be negative, which is what I got when I did it the second way. I got a sine curve. Okay. Now, I did that so that you would be able to tell what we want to use here. Do we want to use cosine or sine on D? And again, let me draw the 4 curves. Hold on, because you need to know this before you can even answer that question. Positive sine, negative sine, positive cosine, negative cosine. Notice the difference. They're just reflections of one another. So, which of those 4 curves am I going to use that would involve the smallest phase shift?
The bottom right one?
Bottom right one, exactly. Because what we just drew is this. That's a negative cosine curve. And it's only been shifted by one grid mark. Each of these grid marks is a third of pi over 2, which means they're each pi over 6. Okay? So that's the first thing. Notice that my other choices would be positive sine. Well, that starts right there. That's 4 grid mark phase shift. Or negative sine. Well, that would start right there. That's 2 grid mark phase shift. Or positive cosine. Well, that starts way over there. That's a huge phase shift. Or negative cosine, which starts right there. That's only a 1 grid mark phase shift. So we know we're going to use negative cosine. Negative a cosine of b times x minus c plus d. That's the one we're going to use. Now we just have to solve for a, b, c, and d. But it helps to know which one we're going to start with, because that's going to be what determines the phase shift c. We have to know which one we're starting with. All right, so what's a?
Maximum subtract minimum divided by 2.
Give me a number.
2 minus 4.
Nope. That's not 4. What is this point right here?
Minus 4.
Okay, then say minus. It's 2 minus a minus 4, all divided by 2. Do not drop negative signs. You have a tremendous desire to drop negative signs, especially if you have a couple of them in a row. You want to drop one of them. Everybody does, not just you. Okay?
Yeah.
People love to drop negative signs. Well, you can't do it. You drop one negative sign, you're getting the wrong answer. So when you're subtracting and you're subtracting a negative number, make sure you put both signs. There's the subtraction, there's the negative number. So what's a equal to?
3.
Okay. D.
Maximum plus minimum divided by 2.
Good.
So it's going to be 2 plus negative 4.
Just give me a bottom line number. We're doing arithmetic here.
Okay. Minus 2 divided by 2 is minus 1.
Okay. Notice what that minus 1 is. That is the new line of symmetry, right?
Yeah.
That's a minus 1. That's what D is. It takes the normal sine or cosine curve and moves it up or down by that amount. Well, this clearly has a line of symmetry that goes through minus 1. That's always what D is that new line of symmetry. Okay. Next one, C. We already kind of figured this one out. That's this distance right from there, because we're using negative sine, to there. What is that?
Yeah. Pi over 6.
And is this curve shifted to the right or to the left?
To the left.
No.
So it's negative.
Nope. Remember what the normal curve looks like.
Oh. Okay, to the right.
Right. In other words, this curve that we're looking at has been shifted by pi over 6 to the right. That is a positive c. A shift to the right gives you a positive c. Now, the last thing, probably the hardest thing to figure out, is b. Just figure out, remember what B is. What's the definition for B?
2 pi over period.
Okay, tell me what the period is here.
It is
Now we only see 2 points here that we can accurately measure, and that's from there to there.
Alright.
But rather than having to figure out what that grid mark is and what that grid mark is, just move one grid over to the left and you'll see we're going from minus pi to pi.
Yep.
So how long is that?
2 pi.
So the period is 2 pi. So B is 1.
Yep.
Now what's the equation?
Y equals 3.
Negative. Remember, we
Yeah.
were using a negative cosine curve.
Yeah.
That's what we determined very beginning, is we're going to use a negative cosine curve. So it's minus 3 cosine. What's the rest of it?
Parentheses x minus pi over 6?
Yeah. In other words, that's your standard right there. X minus C. Well, we figured out that C had to be positive because it was a shift to the right. When you're shifting to the right, C is positive. What's the rest of it? What's the D?
Minus 1.
There's your answer. In other words, you're always going to get these right if you do the exact same process every time. There's no reason to ever miss one of these. It's not complicated. It's just you got to remember. You got to remember what A is, got to remember what D is, got to remember what C is, and you got to remember what B is. Excuse me one moment. Okay. Dog's having a little seizure here. I want to make sure she wasn't at the top of the stairs. All right, Lachlan. Why don't we call it a day here? We started at 5, right?
Yeah.
Yeah. I will talk to you next time.
All right. Thank you.
All right.